Right, well, good morning, ladies and gentlemen. My name is Andrew Ridyard. Thank you for the introduction from Debbie. And thanks to IMI for inviting me to speak today. I'm going to be talking about, well, it's a UV system that applied to improving the quality of printed labels using a digital web press. So the agenda, first of all, in the press release, I'll talk about Excelerate the company, talk a little bit about matching ultraviolet sources to the process, the reasons and advantages of using a low-intensity dose of UV before the final curing stage, some of the test methods for evaluating such a system, look at some print test results, and talk about specifically a single-pass printing application for labeling and how you can actually enhance the print quality using penning and what sort of technical requirements you need for such a system. And I'll summarise and conclude where we are with it. So, as I say, in the best traditions, a little bit about Expo. We're in fact a Canadian company. We've got 4 primary locations in the US and Canada. The particular one that our part of the business is located in Mississauga in Canada, which is near Toronto. We're a reasonable sized company. We're actually listed on NASDAQ and also on the Toronto Stock Exchange. Our main business out of Quebec is manufacturing test and measurement equipment for telecom systems, but the precision assembly side of the business and the life sciences side of the business is actually located, as I mentioned, in Mississauga. Sure, it's how to pronounce it. So we are a global company. We've got operations in North America, Europe, also in the Far East, including China. And the part of the business that I work for is manufacturing UV systems, as I mentioned. And so just want to talk a little bit about where we came from, the reason why I'm talking to you today. We actually manufacture light-based curing systems. We've been doing that for about 25 years. We were known as EFOS before Expo acquired us in 2001. We've got more than 10,000 systems installed worldwide. And we're an industry leader in certain specific manufacturing processes where failure is not an option. And that's an important thing. So we manufacture medical devices, for example. The stability and the output of UV for manufacturing those processes is a very key part, critical part of those processes. So we've got sales in countries all over the world, direct sales and also through distributors. And we've got a very diverse range of markets and applications. We've actually got a series of innovations that have occurred over the years. We have closed-loop feedback, for instance, on our UV systems, which maintains a constant output through the lamp life, through the life of the lamp. We were the first to come up with a commercial optical fibre system, sold in numbers for inkjet applications. And we were also the first, actually, in 2000 with a high-power LED curing system, which I'll talk a little bit more about. So, how's that relevant to inkjet in general? Well, this is the digital web press, digital web label press, and that's manufactured by ITI. I think most of you in the room will know ITI. I think everyone will know Sun Chemical. It's manufactured by ITI for Sun Chemical. And that's really the challenge that we were faced with. We had this challenge of applying to digital web press UV for improving the print quality on a wider range of substrates. Well, this system for printing onto narrow web labels, I think most people in the room appreciate the advantages of digital printing, and particularly applied to narrow web labels. There's economically viable short runs when compared to analog traditional printing processes, and by that I'm talking about Flexo, for example. It's on-demand printing, comparable quality to Flexo, and I do have a print example with me, and Mark Bale from Sun Chemical will be talking as the next speaker. He has some other examples. Minimal setup time and material loss, all of these kind of advantages are pretty well understood and desirable. Comparable production throughput to Flexo, that's an important point. So we're not talking about necessarily maximum peak speed, but in terms of production throughput, useful output in any given day, definitely production throughput is comparable to Flexo. Mass customization, variable printing, and onto a wide variety of paper and film substrates. So that machine designed by ITI is 4 single-pass printing. It's a fixed array of inkjet heads, 4 process colors, CMYK, 3 heads wide, very high accuracy in terms of registration, less than 50 microns over any given distance you care to mention, and speeds up to 24 meters per minute. So that's 80 feet per minute. So let's see, first of all, what we need to cure an inkjet process. Well, we've generally got a free radical style chemistry, and that's specifically what I'm going to talk about. We're not really looking at cationic inks at all. It's all free radical. I'll talk a little bit about the types of UV sources that are available, and all the choices are quite limited. And a little bit about the effects of oxygen, which is all around us, and how that can actually impair the process. So, first of all, what does a free radical UV inkjet process need? There's within any given ink formulation, free radical, there's a number of elements that you'll see. Perhaps the most important is the photoinitiator. It's certainly the most expensive part of the ink, generally. Typical photoinitiators that we're talking about have absorption in the middle, sometimes known as the UVA region of the spectrum. So we're talking, absorptions around the 350 to 370 nanometer region. So that's where the UV is doing its job in terms of the traditional mercury arc spectra, but also with LEDs. I'll talk more about that. You've also got within the formulation, of course, it's an ink, so there's a pigment, and that is going to be doing its best to absorb. So it's very much a case of matching absorption spectra of the photoinitiator and not blocking it too much by the pigment.